I am proudly presenting world this I'm presenting world SDArLo AI artificial intelligence integration into 3ds Max. So starting from the beginning, I decided to directly mention this important statement that without SDArLo AI integration, without the help of SDArLo AI, I never will be able to complete this work, this modeling. This is a floppy disk, more correctly, floppy disk, and it may have look like simple kind of shape, but it actually do contain very minor and precisely shaped details and very non-usually distributed kind of forms. And in terms of preserving polygonality of these polymesh, so their details are so extended throughout the surface. It's very complex to achieve a result, perfect result, polygonal in terms of polygonality, in terms of shape details. So they are very extended. They are very some settle and precisely these details should be precisely and very very explicitly exposed. They should be explicitly exposed, so they will be exactly being identified as a part, as a shape, a part of constructive detail. So after applying OpenSubdiv, the shape should be preserved. As you can see, as I'm applying OpenSubdiv, my shape is preserving. This is the most important kind of requirement, and here is floppy drive disk. Let's see its assembled components, from which part it is assembled. So it's exactly replicating the real world prototype. So here is a body which consists from top and bottom sections. So here is its top section. You can see that it's 100% corresponding to a real world replica. let's look it from without OpenSubdiv applied, and here turn on OpenSubdiv and look how details are preserving, shape is preserving 100%. All these minor straightly and perfect curved indentions are replicated and preserved. So this is the top section, this is the bottom section. So let's see it from without OpenSubdiv, and then turn on OpenSubdiv. Okay. It's not yet finished, but it's kind of a completed state which I can demonstrate. That's why I'm doing it. It's not, there is some still some little kind of little or minor work that still need to be kind of applied for this project, I guess. And after that it will be declared as a complete work. But it's at this state, it's practically, you can say it's completely done. So let's see what else. It contains also a sliding cape. Let's see it. This part or assembly part might seem simple, but it actually is very complicated in terms of these minor holes with their precise shapes, precise measurements, and compared to each other. So you have to, the difficulty was to preserve their dimensions, their places where they should be, and kind of model this detailed sections. And to with that preserve their exact dimensional measurements corresponding to real world. This was very difficult. This might seem easy, but it wasn't easy. It will never be easy to doing this kind of complex polymodeling, and with all of that I preserved 100% polygonality. So as you can see, after applying OpenSubdiv, I'm preserving my design shape, polygonal polymesh shape. So let's move to another component, kind of, for this project. And this also might seem easy. Well, this disk can be defined as easy. It's not that much complicated. Just to draw some circle and kind of, there's not much. All the complexity just to match this shape it with its polygonality to this metallic center holder. So let's just temporarily move forward to this metallic shape. This is complex. This was complex, and as you can see, complexity was with these two holes to integrate into this kind of body, into this body, metallic, just one piece of metal, and to integrate these holes inside this metal and preserve their polygonality and preserve their exactly geometrical shape corresponding to real-world replica. So this step it, because we zoom in so closely, this step it polygonal kind of polygonal flow is because of subdivision leak of polymesh. So as you can see, as I'm increasing my subdivision, this step-it appearance is eliminating. So I'm just leaving it into one, and there's no need to zoom in that much. But as you can see, as some increasing poly subdivision, it doesn't matter, the shape is staying the same. So my shape is preserving, polymesh design is preserving, so it's just a choice. Subdivision level is a choice demand for the situation, as much as you are zooming in for rendering purposes. So that's it. I'm mentioning one more time, I would never be able to complete this this project without help of SDArLo artificial intelligence integrated into 3ds Max. I guess that's all. Just one more time to demonstrate. One more time I want to present kind of perfect work I've done. With the help of SDArLo AI. All the minor constructive and decorative shapes are 100% polygonally perfect, which is proved by applying OpenSubdiv and preserving polymesh design. That's all, I guess. That's all. SDArLo AI integrating in 3ds Max. Also, I have to mention that there is also usage in this for completing this project. I've used the SDArLo Scene Manager, but SDArLo Scene Manager wasn't enough, so I was forced to integrate SDArLo AI into 3ds Max to be able to complete this work. So was used throughout this project completion. Was used SDArLo AI, SDArLo Scene Manager, and SDArLo Polymodeling. SDArLo Polymodeling is production technology. It's a production technology. SDArLo AI and SDArLo Scene Managers are tools, kind of used throughout production and completion. So it's tools used throughout production technology, taken considered as a whole process, one complete process. So I guess there's a lot of I can talk about, but in this scope of this video recording, I don't see anything else that is worthy for mentioning. So I guess I'm gonna just cut it. That there's not more corresponding to this recording to mention this time. So that's all. The most important thing, SDArLo AI. Without SDArLo AI, I wouldn't been able to complete this work. That's all.